Welcome back to All This Math. This is Professor Parker, and on this lesson, we're going to find the discriminant. We're going to find the discriminant. But before we get into that, I want to give a shout out to Morgan State University. This is my undergraduate alma mater located in Baltimore, Maryland, known as the National Treasure. So do some research, become familiar with Morgan State University, an elite, historically black college located in Baltimore, Maryland. All right. Also, make sure you subscribe to the YouTube channel at All This Math. Turn on the post notifications so you'll be alerted when I put out new content. All right. Now, we're going to find the discriminant of what, though? We're going to find the discriminant of this equation. All right. Now, this equation has a lot going on. This equation is like long for no reason, right? It's a lot. It's real extra because it's like this expression right here on the left-hand side itself could be an equation by itself if it was set equal to 0. Or this expression over here, if it was set equal to 0, could also be its own equation. But for some reason, whoever created this equation, they wanted to test your ability to put a quadratic equation in standard form. All right, now why did I call it a quadratic equation? Because the biggest exponent we see is a 2. Those are the biggest exponents we see, are 2's. All right, so that means it's a quadratic. So first thing I'm going to do is I'm going to try to put this in standard form where everything is on the left-hand side of this equal sign and I got a 0 on the right-hand side. That's what I would do. I messed up my 4. All right. But before I do that, let's talk a little bit about what a discriminant is. Like, what is a discriminant? Like, what is it? Right? It's a math term that we throw around a lot. And as teachers, sometimes we take for granted that people even know what this is. A discriminant is a piece of information. It's a number. It's a number that tells us information about what the solution to a quadratic equation will be. That's what a discriminant is. All right. Now, when you calculate this discriminant using a formula, let me write the formula down. It's part of the quadratic formula, right? The discriminant is a part of the quadratic formula. And it's this right here, b squared minus 4ac. That's part of the quadratic formula. Anybody that's familiar with the quadratic formula, you know that this part right here, this expression, is the part that go under the radical sign, right? That's what this is. Once you plug the right numbers in the place of b, a, and c, then what's going to happen is that's going to give you a number. Once you get that number, you only got 3 options. Either the number going to be positive, or it's going to be 0, or it's going to be negative. It can't be nothing else. All right. So 0, positive, and negative, right? So depending upon what it ends up being, whether it's positive, negative, or 0, that's going to determine how many solutions you're going to have, how many real number solutions you're going to have when you go through the trouble of actually solving this. Now, to be clear, we don't got to solve this. We only got to find the discriminant. And the discriminant is a number that gives us information about what the solution would be if we did decide to go ahead and solve it. So if the discriminant is positive, that means that if we solved it, we would end up with 2 real number solutions, all right, or roots or answers, basically. If the discriminant was a 0, if this added up to 0 or the difference was 0, then we would have 1 real number solution. If the discriminant was negative, then that would mean that we would have no real number solutions. We'd have 2 imaginary number solutions. That's what happens when you have a discriminant that's a negative number. All right. So now let's get into it. And let's first put this in standard form, because before we could use this formula, this got to be in standard form. So before we use this formula, this got to be in standard form. Now, how do we put this in standard form? By moving everything to the left-hand side, combining like terms, and then we end up with 0 on the right-hand side. So this is what I'm going to do. I'm going to rewrite everything. I'm going to rewrite the whole equation. This is one way to do it. There are other ways to do it, but I like doing it this way, so I'm going to show you how to do it this way. So I'm going to do this. I'm going to rewrite these 3 terms. So I got 5x squared minus 49x plus 421. And then watch this. Watch what I do with this x squared. I'm going to slide it to the left, but it's going to become negative. I'm going to slide this 7x to the left, and it's also going to become negative. I'm going to slide this negative 3 to the left, and now it's going to become positive, because whenever you switch the side, you change the sign. That's called transposing. There's a word for that. It's called transposing. When you take a term in an equation and move it to the other side of the equal sign, and change the sign, that's called transposing. So now I moved the negative 3 to the other side, now it's a positive 3. I moved the 7x to the other side, now it's a negative 7x. I moved the x squared to the other side, now it's a negative x squared, right? Now I'm gonna combine like terms to like clean the problem up and everything. So I look for all my x squareds. So I got 5x squared and negative x squared. Then I got negative 49x and negative 7x. I'm gonna match them up, right? These two I underline because I'm gonna match them up. These two I circle because I'm gonna match them up. And then the 421, put a check mark on top, and the 3. Those are constants. These are constants, right? So I'm gonna match them up. They don't have a variable attached to them. They're constants. So now I'm gonna do the math. 5x squared minus x squared is 4x squared. Negative 49x and negative 7x is negative 56x. 421 plus 3 is 424. So that's my equation in standard form. Now again, we only finding the discriminant. We're not solving this. We're not about to break out the whole quadratic formula and solve for x. That's not what we're doing. We only want to know what the discriminant of this equation is. So now we go to this formula. B squared minus 4AC. Now, what you need to know in order to use this is, you need to know what numbers B represents, and A represents, and C represents. That's why you had to put it in standard form. Because once you put it in standard form, you know that the coefficient of the x squared term, that's your A value. Let me switch the color up for you real quick. So this right here is your A value. Always. The A is connected to the x squared term. This right here is your B value. The B is connected to the x term. And the constant that's by itself, that's your C value. When I was in middle school and I learned how to do this, the way I remembered it was the first letter in the word constant is a C. So the constant is your C value. So that's my A, that's my B, and that's my C. And that's how it's set up whenever you're dealing with a quadratic formula or a quadratic expression. That's A, that's B, that's C. So now you can use this formula now. Now you can use it. All right, so we want to do B squared minus 4AC. Now what's B? B is not 56. You look at it, you might say, oh, it's 56. No, there's a minus sign in front of it. So B is negative 56. And what you should do is you should put that number in parentheses anyway. So B in parentheses, and then put the exponent 2 outside. Then the minus sign, then the 4, because that's just a 4, then times A. A is 4, right? So A is 4 right here. So this is 4 times A, or 4 times 4. And then we got C. C is 424, right? All right, so now, these numbers are pretty large. I did these calculations already, so I'm about to go grab my notes so I know what the numbers are. Negative 56 squared is 3,136. Negative 4 times 4 is negative 16, because the negative times a positive is always a negative. That's negative 16 times 424 is going to be negative 6,784. So you see what's about to happen, because this number is bigger than that number. So 3,136 minus 6,784 is equal to negative 3,648. So this number right here, this is the discriminant. This is the discriminant. Negative 3,648. Now, what does that tell us? Why do we care? Now that I know that the discriminant is negative, I know that if I was going to solve this, this would not have no real number solutions. It would have none. It would have 2 imaginary number solutions, but it would not have 2 real number solutions because it's negative. If it was a 0, that means it would have 1 real number solution. If it was positive, it would have 2 real number solutions. But because it's negative, it has 2 non-real number solutions. All right, and that's why that's important. That's why that's important to know. All right, it gives you information What the discriminant does is it gives you information about the answer. It don't give you the answer. It's not the final answer. It's not the solution to the equation, but it gives you information about the solution to the equation. So you know what to expect if you got to graph it, or if you actually do go through all the process of actually solving it. You know what I'm saying? That's what it does. So discriminant, this is the formula for the discriminant. It's part of the quadratic formula, which is a larger formula. X equals negative b plus or minus the square root of this right here, all divided by 2 times a. And you notice how I kept using, variables a, b, and c. Make sure you know this. This is a, this is b, this is c. And it helps to put the terms in order. But even if the terms wasn't in order, just know that a always match up with the x squared term. And it don't matter what the variable is. It could be j squared or r squared or d squared. It don't matter. Whatever exponent, whatever variable is raised to the second power, a is the number that's attached to that. B is attached to the term, to the variable that's raised to the first power. But you don't see no 1 written here, right? Because you don't have to write the exponent 1. We never have to write that. It's understood. It's like what's understood don't need to be said. It's like that. So if this is an x, that means it's automatically x to the first power. 2 is you got to write it. If 2 is your exponent, you got to write it. If 3 is your exponent, you got to write it. If 4 is your exponent, you got to write it. But the only exponent you don't got to write is a 1. Because if you see an x, you automatically know. You got to just know that's x to the first power. And this is your constant. So this is c. And b matches up with the x to the first power term. C is the constant. All right? So, but again, before we even got into that, you had to put this in standard form. So that means everything had to go on the left-hand side. Now, if you wanted to, a lot of teachers probably show you this instead. Instead of transposing, right? Because transposing is like a shortcut. That's something like you kind of graduate to. Like once you get like a little nice with this and you know how to like manipulate and move the numbers around, you could transpose as a shortcut. But a lot of times, a lot of teachers will teach you to use the addition property of equality, right? So you would take the opposite of this. You would subtract x squared on the right side, subtract x squared on the left side. You're still going to end up with this. Subtract 7x on the right side, subtract 7x on the left side. You're still going to end up with this. Do the opposite. Add 3 on the right side, add 3 on the left side. You're still going to end up with this. All right? So that's a little bit about how to find a discriminant. But find some other examples like this, because this video is a good guide for you, but you won't master this skill or become proficient until you practice and do a bunch of examples on your own. So ask your teacher, ask your professor, ask whoever to give you some more examples that look just like this with different problems so you can practice and get that working. All right? So you'll be able to do it by yourself. All right? So go get some practice, and I'll catch up to you in the next video. Peace.